All right, welcome to your last lesson of the 2020 school year. Congratulations on making it here. I'm sure everyone's ready to be done. So let's do it. Let's get done. Quick warm-up. What we did yesterday. Find the slope of the tangent line at the given x values. So reminder, when I take a derivative, it gives me a formula to find a slope of a tangent line at a certain point. So if they give me a function and a given x value, if I find the derivative of that function and plug in the x value, it gives me the slope of the tangent to the curve at that exact x value. So let's do it. So let's find the derivative. We get negative 6x squared. So I'm just using the power rule to get my derivative here, and the 5 goes away. And now I'm going to plug in negative 4. So negative 6 parentheses negative 4 squared. And if I just type that into my calculator, let's see, what do I get? Negative 96. Right, because negative 4 squared is positive 16 times negative 6 is negative 96. That is the slope, and that's all I'm looking for in this problem. And one more, you can do this one. I'm going to do it a little bit faster, a little less explaining, a little more math. My derivative is going to be an 8x minus 2, plugging in the point. F prime of 1 is going to be 8 times 1, which is 8, minus 2 is 6, and that's my answer. So the slope of the tangent at x equals 1 is 6. You may be wondering, like, what does she mean, the slope of the tangent? What I mean is this. Let's just say this curve looks like this. Okay, whatever. It could just look like something curvy, and then here is x equals 1. So at x equals 1, here's the point. The tangent line is this blue line that I'm drawing in that like just touches that point. So we're looking for the actual slope of this tangent line. All right, that's what we're talking about. That slope of the tangent gives me what's called an instantaneous rate of change. So what's the rate of change at that exact moment? Okay. So that's just kind of what's actually going on. And today we're going to take it a step further. We are now going to write a whole equation of the tangent line. Okay, so what I absolutely love about this is it combines calculus. The part that's calculus is taking the derivative. Plugging in a value, evaluating, that's algebra 1. Okay, writing the equation of a linear function, that's algebra 1, maybe some algebra 2. So this really takes stuff we've learned since day 1 and applies it into calculus, which is pretty sweet. When you take a real calculus course, guys, what you will realize is that algebra 1, geometry, algebra 2, trig precalc, it all funnels into calculus, and it's a beautiful, beautiful thing. Guys, I got 3 types of problems for you today. Here we go. First one says this. I'm going to give you a point, okay? Then I'm going to give you a function, and I'm going to say write the equation of the tangent line at this point. So here's what we do. First, find the derivative, because that will help me find the slope of the tangent line, right? So we get 6x squared plus 2x minus 3. That's my derivative. Now I'm going to plug in the x value of the point. We will use the y value at the end of this problem, but right now we ignore it. Okay, f prime of 2. I'm just plugging in 2. I suggest just using a calculator. So in your calculator, literally type 6 parentheses 2 squared plus 2 parentheses 2 and then minus 3 and hit enter. That's going to be a lot faster than doing this mentally, and I got 25. So that is the slope of the line. okay, of the tangent line. Now what I'm going to do is write the equation of the tangent line, and what I'm going to do, guys, here comes algebra 1, is I'm going to write it in point slope form. This is point slope form. You know, in the past, sometimes we make you write it in slope-intercept form, but just because it's the end of the school year, it's been a crazy, psychotic year, screw it, we're just going to stick with point slope, which is, believe it or not, a lot easier, because then I don't have to do any more work. Once I plug it into this formula, boom, I'm done. So, my y value in my equation comes from the point, the y value of the point. The x value in the equation comes from the x value of the point. And last but not least, the slope in the equation comes from that derivative that I just plugged into. So I've got all the pieces of the puzzle. We just plug and chug, guys. Y minus y1 is y minus 7 equals the slope that I found, 25, parentheses, x minus the x value, which was 2, and bada bing, bada boom, I'm done. That's it. That right there is the equation of the tangent line. You know what? Because I look at my most recents, I've been watching Hulu on this thing all day. Here we go. I'm actually going to show you something here. So let's type in the equation 2x cubed plus x squared. 2x cubed plus x squared. What else was it? We got minus 3x minus 7. Couldn't find it for a second. My eyes didn't know what to do. Crazy. Okay. So here is the curve. The equation of the tangent line is y minus 7 equals 25 parentheses x minus 2. So y minus 7 equals, I can't remember already, 25 parentheses x minus 2. All right, it's kind of hard to see because it's really steep. But if you zoom in enough, okay, you can see that this blue line is a tangent line at x equals 2. Because it hits at 2, 7. And if I zoom out, you can really see that that blue line is just touching, skimming that curve right at that point. That's what we're doing. We just wrote that equation of that blue line. Pretty sweet. All right, a couple more here. This one's going to go a little bit faster. Let's just solidify this skill. Find the derivative. Negative 2x plus 10. Plug in the point. So we're plugging in just the x value. Negative 2 times 3 plus 10. Plug and chug that into your calculator. We get 4. That's the slope of the line. Okay, next we're going to write the equation, and that's it. My equation is going to be y minus the y value of the point, which is 20, equals the slope, which was 4, parentheses, x minus the x value of the point, which is 3. Perfect. Let's take it another step further. So this part is interesting. Here's why. It only gives me an x value. It doesn't give me a whole point. So, how do I find the other part of that point? How do I find the y value of the point? To find the y value of the actual point, we plug into the original function, okay? Now this starts to get confusing. Wait, when do I plug into the original function? When do I plug into the derivative? Here's the moral of the story. Plug into the original function, gives you the y value of the point. Whenever you're plugging into a derivative, it is always giving you a slope. Always, always, always. The derivative is a formula for the slope. Okay, so let's start these problems by first just plugging in to the original function, and that should be a negative one that I'm plugging in. Plug into the original function. So 2 parentheses negative 1 to the 4th plus negative 1 squared plus 1, okay? Plug and chug that into your calculator. So you're literally in your calculator going to type 2 parentheses negative 1 to the 4th, and then plus parentheses negative 1 squared, and then a plus 1. That is 4. What this gives me, not the slope, because I didn't plug into the derivative, I plugged into the original. This gives me the point. This is the y value of the point, okay? Now this problem is the exact ones we just did, right? So now I'm going to find the derivative. Okay, 4 times 2 gives me 8x cubed plus 2x. That's my derivative. Plug in the x value of the point. So f prime of negative 1. Remember, if I'm plugging into a derivative, I'm getting a slope. Okay, so let's see. We get negative 8, negative 2. So we get negative 10 here. This is the slope of the tangent line. Now I have a point, I have a slope, I can write an equation. What do I need to write an equation of any line ever? A point and a slope. That's all you need. If you have those two things, you're golden. You can write an equation. Now, minus negative 1 turns to a plus. So this is the equation. All right. Ta-da! Let's do that again. Starting by plugging in to the original function to find the y value of the original point. Oh, silly me. I wrote 16 here, but that's because I was doing 8 times 2 in my head. This should be plus 10. So I got 18. Okay, when I plugged in. So that means the point is 2, 18. That's the point. Next, let's find the slope. To find the slope, we find the derivative first. Okay, 12x minus 8 is the derivative. Now, plug in 2. Okay, 24 minus 8 is 16. That's the slope of the line. Now I've got the two things I need. I've got a point, I've got a slope. Let's do it. Y minus 18 equals the slope, 16, parentheses, x minus my x value, which is 2. Ta-da! Gorgeous. All right, last type of problem. This is working backwards. What if I give you a slope? Can you tell me the point in which the line is tangent at that slope? Okay. Essentially, here we go. This is a slope. If you're working with a slope, you want to work with the derivative. So what we're going to do is set it equal to the derivative. Okay, so first let's find the derivative. Oopsies, let's drop down the 2. 2 times 3 is 6x. That's it. Cool. So now what you do is you take the derivative and you set it equal to the given slope. So we get 12 equals 6x. Now solve for x. So let's divide over 6. So we get x equals 2. What this means is the slope of the tangent line is 12 at x equals 2. It asks me to find the whole point. If I want to find the entire point, I plug my x value into the original function. So go back to the original function. That's 3 times 2, quantity squared, minus 5. Okay, let's see. 2 squared is 4, times 3 is 12, minus 5 is 7. So the point is 2, 7. At this point, the tangent line will have a slope of 12. That's the whole idea. All right, last problem to just solidify everything. Okay, find the derivative. 6x squared minus 3. Okay, now slope is 3. plug in. 3 equals 6x squared minus 3. Solve for x. So I'm adding 3 over. I get 6 equals 6x squared. Divide 6. I get 1 equals x squared. And to solve this, let's go ahead and square root both sides. Now, of course, guys, I love it. This is where the algebra 2 comes in. We get plus or minus 1 equals x. Right? When I square root, it's positive, negative. So that means that there's 2 points. At the point 1 something, there's going to be a tangent line with a slope of 3. And at negative 1 something, there's going to be a tangent line with a slope of 3. So no worries, we just have to find the original points with both of those numbers. So first let's find the original point when x is 1. Plug into the original function. 2 times 1 cubed minus 3 times 1 plus 1. Okay, so that's 1 cubed is 1, so 2 minus 3 is negative 1 plus 1 is 0. Okay, so the first point is 1, 0. And the second point, let's find f of negative 1. Okay, so what do we get? Negative 1 cubed is negative 1. Negative 2 plus 3, we get 2. So this point is negative 1, 2. Okay, so at these 2 points, at 1, 0 and at negative 1, 2, if I find the tangent line, it's going to have a slope of 3. So that's the moral of the story. I know that that was definitely kind of fast, but hopefully it sunk in. Try the worksheet, and that's all. You're done for the year. You got a quiz, but that's it. All right, thanks, guys.